Humanity's energy challenges may find solutions within the human eye, according to pioneering research. This research has identified subtle, yet powerful visual anomalies in the eye. These anomalies are not merely biological curiosities, but hold deeper significance. They are considered a key to unlocking a fundamentally new form of energy. This discovery suggests a potential paradigm shift in energy generation and understanding. A potential new power source is manifesting as a subtle shimmer. This shimmer is perceivable only at the edge of vision for some individuals. While some observers dismiss it as an optical illusion, its nature remains debated. It is believed to be the signature of a monumental scientific breakthrough. A compelling phenomenon suggests a genuine, pivotal, energetic presence. This presence may have been systematically overlooked by mainstream science. Its subtlety is identified as its greatest disguise, hindering detection. The phenomenon is not an obvious, overwhelming force. Instead, it manifests as a delicate, ambient field. Initially, the detection of this radiant phenomenon is limited to a small percentage of individuals. However, human perception can be significantly enhanced through structured training. Simple, patient guidance enables the majority of individuals to perceive this phenomenon. This training expands human potential by broadening sensory and cognitive capabilities. The narrative of unseen energy is intrinsically linked with human evolutionary development. Our visual system evolved with optimizations primarily for survival in various environments. This optimization may have inadvertently filtered out powerful, pervasive signals. The exclusion of these signals likely served to prevent visual clutter, aiding focus on critical information. Evolutionary processes have shaped human perception over millennia. The visual system developed to prioritize essential survival information. This involves subconsciously filtering out less critical energetic signals. Such filtering allowed ancestors to focus on immediate environmental tasks. Key tasks included identifying potential dangers in their surroundings. Another crucial task was efficiently locating sources of sustenance. Human eyes exhibit diverse capabilities, with individual variations in visual perception. Some individuals possess superior color discernment, perceiving a wider spectrum of hues. Others may even have extra color receptors, enhancing their visual range. Despite inherent differences, the ability to train the eye for specific visual phenomena is widespread. Most individuals possess the capacity to learn to perceive subtle energy through diligent practice. This perception is a trainable skill, accessible to a wide range of people. A dedicated subset of individuals can even discern the specific color of this energy. The ability to define its color indicates a consistent and observable characteristic of the energy. A foundational hypothesis proposes that observed anomalies indicate a new form of energy. If this hypothesis is confirmed, it would validate the existence of this novel energy. Such confirmation would highlight the human eye's extraordinary detection capabilities. The eye would then be recognized as the most sophisticated natural detection instrument. The human eye is a sophisticated biological instrument for perceiving light. It is specifically adapted to detect electromagnetic radiation within the visible light spectrum. This visible spectrum represents a small portion of the entire electromagnetic spectrum. Beyond visible light, other forms of electromagnetic energy exist, such as radio waves and X-rays. Intriguingly, some theories propose the existence of non-electromagnetic energy within this visible range. This hypothetical energy is believed to subtly interact with the retina, influencing perception. The concept introduces a new form of energy, distinct from conventional light. This energy is not a direct counterpart or opposite to light. Instead, it functions as a complement to existing light phenomena. It shares some characteristics with light, indicating a partial overlap in properties. Crucially, it does not possess all properties typically associated with light. This suggests a unique interaction mechanism with matter, differing from light's behavior. Our visual system actively processes incoming light and energy, A significant portion of this energy is filtered out during visual perception. This filtration is a complex act of biological processing within the visual system. Ironically, this biological filtering mechanism obscured the new energy's presence. Consequently, its existence remained hidden from conventional scientific understanding for a long time. Standard image capture devices, such as cameras, operate on specific chemical principles. These devices are designed to register visible light and certain other electromagnetic spectra. However, they often fail to detect subtle energy forms that do not align with their operational chemistry. This limitation means certain energies remain unrecorded by conventional photographic equipment. Conversely, the human eye possesses a unique biological mechanism for detecting such subtle energies. Thus, the human eye serves as the primary and most crucial detector for these specific energy types. The perception of a radiant field is often described with remarkable consistency across individuals. Observers consistently report its color falling within the blue, indigo, and violet spectrum. This uniformity in color description is a significant observation. Such consistent reporting provides a crucial piece of evidence for scientific inquiry. It suggests underlying objective properties or shared perceptual mechanisms. This consistency offers a valuable clue for further scientific investigation and analysis. Historical texts describe a consistent color associated with human vitality. Early observers, lacking scientific tools, noted a pale violet gray or blue-gray field. This description aligns with modern observations, indicating a persistent perception. The described field was often characterized as faintly luminous. It was historically believed to be directly tied to an individual's human vitality. The N-rays affair in 1903 caused significant setbacks for open-minded visual research. This historical event highlighted challenges in scientific validation and acceptance. However, the 21st century offers new concepts and discoveries. These advancements are poised to resolve long-standing scientific riddles and overcome past limitations. The first key anomaly is a distinct visual effect, often referred to as an aura or border. This visual effect can be observed around various objects. It appears around both living and non-living entities. The anomaly manifests irrespective of the object's inherent color. The border of an aura is not static, indicating a dynamic phenomenon. When observed closely, this border appears non-existent. However, as the distance from the observer increases, the perceived size of the border grows. This characteristic suggests a strong correlation with optical principles. The expansion of the border with distance implies an optical effect. This effect is related to how the energy propagates and interacts with light. Aura perception is a phenomenon that a significant portion of the population can learn to see. Studies suggest that up to 50% of individuals can be trained to perceive this visual effect. To experience it, one must hold a hand or any other object against a plain, brightly lit background. Concentration is key to perceiving a faint, smoky, blue-violet edge about 1 or 2 millimeters around the hand or object. This technique allows individuals to observe a subtle but consistently wide visual aura or energy field of about 2 millimeters. A luminous aura is a phenomenon perceived by some individuals. This aura cannot be captured by conventional photographic methods. This inability highlights a distinction from ordinary light, which is photographable. The human eye serves as the primary and most important detector for this aura. This confirms the unique role of human perception in detecting such luminous phenomena. The human retina exhibits astonishing sophistication in processing light frequencies. A notable anomaly exists concerning the blue light frequency range. This indicates a specialized mechanism within our retinal structure. This mechanism suggests an advanced adaptation for filtering blue light. The human visual system interprets color through specialized photoreceptor cells called cones. There are 3 distinct types of cone cells, each sensitive to different wavelengths of light. These are commonly referred to as red, green, and blue cones, corresponding to their peak sensitivities. Red and green cones are present in high abundance across the retina, contributing significantly to color perception. In contrast, blue cones are remarkably rare, constituting only about 2% of the total cone population. The blue-violet frequency range exhibits a dramatic and mysterious filtering. This phenomenon involves a profound reduction in the intensity of blue-violet light. The filtering appears to be highly targeted, affecting only this specific color band. Such a precise reduction suggests an underlying mechanism at play. The selective nature of this filtering implies a potential biological purpose. Understanding this targeted frequency reduction is key to unraveling its biological significance. In electronics, a filter amplifier system is used to refine signals. The filter component specifically targets and removes unwanted noise signals. Following the filter, an amplifier boosts the desired, cleaned signal. This analogy applies to how the eye processes blue light, filtering and amplifying specific signals. Biological systems often exhibit what appears to be random noise in their signals. However, in certain biological contexts, this noise is not merely random interference. It is hypothesized to be the signature of a fundamental, previously unrecognized energy source. Specifically, within the visual system, this noise is actively managed. The visual system processes and utilizes this signal, suggesting its energetic significance. A notable resonance exists between two distinct anomalies. The first anomaly involves a visible aura, consistently described as blue or violet in color. This blue-violet aura is a frequently reported phenomenon. The second anomaly concerns the human eye's filtration capabilities. The eye exhibits the most dramatic filtration specifically within the blue frequency range of light. This strong ocular filtration of blue light resonates with the observed blue-violet aura. Recent scientific findings have identified a specific chemical amplifier. This amplifier selectively boosts the blue signal before it reaches the brain. It enhances the blue signal without affecting other color signals. The green and red signals remain untouched by this chemical process. The visual system actively manages incoming light frequencies. This management involves a combination of aggressive filtering mechanisms. It also includes selective amplification, specifically for blue light frequencies. This dual action provides strong biological evidence of active processing. It indicates that non-standard energy input at blue light frequencies is regulated. The visual system thus demonstrates sophisticated control over specific light inputs. This engineering blueprint details a filter and amplifier system. The system is crucial for understanding future power sources. It provides insights into advanced energy capture mechanisms. In-depth study of this design is essential for technological advancement. The blueprint represents a foundational step for next-generation energy solutions. Its principles will guide the development of sustainable power systems. The universe contains an unseen component known as dark matter. Dark matter constitutes approximately 85% of the total mass of the universe. Despite its prevalence, dark matter does not emit or reflect light, making it invisible. A faint glow, often described as a visible aura, can be observed in certain phenomena. This faint glow is attributed to a scattering effect. Dark matter is hypothesized to be the source of this scattering effect, explaining the visible aura. Dark matter is an enigmatic substance that pervades the universe, yet remains unseen. It forms vast, invisible clouds that continuously pass through all matter, including us. Often described as a cosmic fog, its presence is not directly detectable by conventional means. Its existence is inferred solely through its powerful gravitational influence on visible matter. This gravitational pull shapes the structure and movement of galaxies and galaxy clusters. Dark matter acts as the fundamental scaffolding upon which the visible universe is built. The aura phenomenon suggests the existence of a new light-like particle. This hypothetical particle interacts with ordinary matter. It is scattered by a pervasive dark matter fog in space. This concept represents a slight modification to the standard model of physics. The interaction and scattering mechanisms are key to understanding its properties. The Z-prime boson hypothesis introduces a new fundamental particle, similar to the photon. This hypothetical boson is proposed to mediate interactions beyond the standard model. Studies of galactic dynamics indicate dark matter interacts gravitationally. Evidence also suggests dark matter experiences a weak nuclear friction interaction. A theoretical massless Z-prime boson is a hypothetical particle, a cousin to the photon. This boson would possess properties similar to light, enabling it to reflect and refract. Such a particle could interact with biological systems, specifically the human eye. It might be absorbed within the eye's blue frequency range, affecting vision. This absorption could theoretically manifest as an aura or visual phenomenon. The weak nuclear force is one of the four fundamental forces of nature. It governs particle decay and nuclear fusion, playing a crucial role in stellar processes. Dark matter particles, specifically WIMPs, are hypothesized to interact via this force. This weak interaction aligns with predictions for how dark matter might behave. This connection offers a consistent theoretical framework for understanding dark matter's nature. Dark matter, an omnipresent cosmic fog, interacts with ordinary matter. This interaction is hypothesized as a potential source for new energy. The dark matter fog itself is believed to cause a scattering effect. This scattering mechanism could release energy from the interaction. Research explores harnessing this fundamental interaction for future energy solutions. Weak nuclear energy presents transformative implications for energy capture. Unlike solar panels, which capture energy based on a two-dimensional surface area, a device designed to capture Z-prime nuclear energy would operate in 3 dimensions. This inherent 3-dimensionality allows for a fundamentally different energy collection approach. A weak nuclear generator operates continuously, providing consistent power output. It functions independently of external environmental factors like weather or daylight. This ensures 24/7 global access to reliable energy, regardless of location. Power generation is directly proportional to the volume of its capture material. This design allows for compact yet potent energy sources, suitable for diverse applications. The process of harnessing universal power involves a structured, multi-step approach. This journey is systematically divided into 3 critical phases: identification, isolation, and utilization. The initial and foundational phase is identification, which is currently the primary focus. Identification necessitates the collection and presentation of undeniable scientific proof. This rigorous scientific validation is crucial to confirm the existence and nature of the power source. The critical next step in identification involves studying proteins within blue cone receptor cells. This research aims to validate a theory regarding energy resonance. Physical evidence of additional energy resonating with the chemical retinal is sought. This evidence should be detectable, even in conditions of total darkness.